Hello there. It's Sunday and we're about to start the third week of your astronomy course online. And I just wanted to say hi. I hope you didn't get too much snow in your driveway. We just got through clearing our driveway. So I'm down here now to talk to you about what you can expect in module 3 of our course. So, if you take a look at the stars that are up in the sky, like the stars that are back behind me, astronomers want to understand, what are those things in the sky? How do they move? What are we looking at? And that is really the science of astrophysics. And that's what my doctorate is in. It's in astrophysics. And I just love learning about how things move in the sky. And that's what we're going to be learning about this week. And specifically, we're going to be learning about Newton's laws of motion and gravity. Isaac Newton came up with these laws back in the 1600s, and he's the one who really started our understanding of how things move. And he came up with 3 laws of motion that talked about how things move, and they are unusual. He was a great genius, and he had to be, because he had to have new insights into how things move. And so I'm just going to tell you very quickly about what you're going to be learning. You should, of course, read about it in your book and go through the homework quizzes. But Newton's laws, there's 3 of them. And the first one talks about what a force does. A force is just a push or a pull. And what forces do? What happens when a force acts on an object? What happens when I exert a force on the ball or I push something? Well, what a force does is a force causes a change in motion. It makes the object either speed up or slow down or change direction. And so that's what Newton's first law is. It says that if there's no forces acting on an object, it will just move in a straight line at a constant speed. And if there is a force, it'll either speed up or slow down or change direction. In other words, it will accelerate. So that's Newton's first law. His second law talks about how much acceleration, how much an object changes its motion, depending on the force that's acting and on how much mass the object has. And it's easier to speed up something if you're pushing a light tennis ball than if you're pushing a heavy bowling ball. And that's basically what Newton's second law is all about. The third law is really a law that we all have experience with, but we've never thought about it that carefully. And it's sort of like if you've ever been in a city where they have a subway, and you're trying to push in and you're trying to get into a car and they're pushing you back. That's the essence of Newton's third law. If I push you, you push back on me. For every force that I push on you with, you push back on me with the same strength force, but in the opposite direction. And you can illustrate that yourself. Just find yourself a rubber band like this one and stretch it out and feel the force on your thumbs. And sure enough, the forces are equal on your thumbs. You can feel the poles are equal. And regardless, you can change how much force there is. You can move your hands around when you're doing it. You can just have a great time. I can amuse myself for hours doing this. And sure enough, what you feel on your thumbs is always the same. That's Newton's third law. Okay. So those 3 laws of motion of Isaac Newton, plus his law of gravity. And Newton's law of gravity says that everything that has mass attracts everything else that has mass. And so regardless of where you are right now, if there's other people in the room, you're attracted to them and they're attracted to you, right? Equal and opposite forces by Newton's third law. So you're attracted to them, they're attracted to you. You're attracted to a car outside on the street. But what are you attracted to most of all? What you're attracted to most of all is the biggest thing around, which is the Earth itself. And that's the cause of gravity. And that is the force that causes all the motions in the universe to change the way they do. So you're going to learn about Newton's law of gravity as well as his 3 laws of motion in this module. So I also want to talk a little bit about what's in the sky, what you can see this week. If it's really cloudy, you may see the underside of clouds. But if the sky is, if you can see, then you can see a couple things. So here is the screen of Stellarium. And you can see here some things we've talked about before. Here's the constellation of Orion with the red giant Betelgeuse, the upper right shoulder. And here is blue-white Rigel. I'm sorry, the upper left shoulder of is Betelgeuse, and the lower right is Rigel. And if you take a look, you can see that there is Orion the Hunter, and there's Betelgeuse, and there's Rigel. You can also see over here is Sirius, the brightest appearing star in the sky. And that's in Sirius. Canis Major is the Latin name of that constellation. So Canis Major is the big dog. And up here is Aldebaran. Aldebaran is the angry eye. I don't know why I say angry eye, but I think of a bull as being angry. It's the red eye of Taurus the bull. And so there's Taurus the bull, and there's his eye. Now I want to show you a little bit what's above that. So I'm going to pull the screen down. And just as a reminder, you're facing south here. That pop-up keeps coming up, but you're facing south. And if you're facing south, over to your left is the east, and over to your right is the west. So I'm going to pull this down a little bit, and I'll turn off the constellations. There we go. So now we're looking higher in the sky, and there's the full moon. The full moon, there's going to be a full moon this Thursday, the 28th. Now, if you go outside a couple days before that, on Tuesday, the 26th, you'll see the moon right here. And the moon is near 2 very bright stars. Here's the star Pollux. The other one is Castor. And Castor and Pollux are in the constellation of Gemini, right here. So if you want to see the full moon, that will be on the night of the 28th, but go out on the 26th because that's when the moon is going to be near Castor and Pollux. Now I have to tell you, if you ask me, do I really see those figures when I look up in the sky? No, I don't. I just see the patterns of the stars, but I like to put the figures up now and again just to show you the figures from Greek mythology that they're named after. And here's still Mars over here to the east that you can see. And here are the Pleiades, that star cluster that you have to know. And just around Aldebaran are the Hyades star cluster. So if you're doing observing project 1, if you're doing the first observing project, just so you'll know, on the 28th is a full moon. And some nights, as the month goes on and you go out to see the moon, if you can't find it in the sky, Stellarium is an easy way to find out just what time the moon is in the sky. Just start Stellarium and you can find the moon in the sky and about what time it's up for you to see. And for those, all you have to do is go out every, 4 nights or so for that moon calendar for observing project 1. And if it's cloudy, just draw in some clouds and that'll be fine. So that's what is going to be happening this week. And I hope you enjoy learning about Newton's laws. And one more thing I'll say about Newton's laws, and that is on the homework, I have you plug some numbers into equations. And the reason I do that is that I want you to understand how astronomers get the results they get, How do they know things like the masses of planets? And as we go on, you're going to be learning some amazing things. Some things may be even, difficult to believe. And I want you to see examples of the sort of the calculations that astronomers do to get those results. But although those calculations are on the homework, they are not on your exam. Right? There's no complicated math on the exam. In fact, I do all the math that's on the exam. All you have to do is recognize which is the right formula, if that's the right formula or not. And you won't need a calculator for your exams. And I will certainly give you any formulas that you need. You never have to remember anything, any formulas like that. So please don't worry about the math. You'll see some math on this week's homework, but this is just me trying to show you how we know what we know about the stars. So everybody, take care. And I hope there are some clear nights for you to go out and take a look at the sky. And I will look forward to seeing you next week. So I will see you then. Bye-bye.